speaker invited for our second session is Dr. Mahedra Patil. Dr. Mahedra Patil is basically a chemical engineer. He obtained his doctorate degree from our Rashtrasanta Tukdoji Maharaj, Nagpur University, Nagpur. And he's working as a scientist in Solid Waste Management Division. He's working as the Chief Scientist and Head of Chemical and Hazardous Waste Management Division, Niri, Nagpur. Dr. Patil has a deep knowledge of the subject matter, which is reflected from more than research paper published in national and international journals of the repute. His area of interest in solid and hazardous waste management monitoring, and he has been a principal investigator of the several projects sponsored by Ministry of Environment and Climate Change, which speaks about the dedication and the commitment towards his work. Now I would like to request Ms. Kani Mozi for some little bit elaborative biodata.
It's my privilege to introduce the resource person, Dr. Mahedra P. Patil, who is the Chief Scientist and Head, Chemical and Hazardous Waste Management Division, CSIR, National Environmental Engineering Research Institute, Navy. He is basically a chemical engineer who obtained his doctorate degree in engineering from Rashtrasanta Tukdoji Maharaj, Nagpur University. Sir has nearly 32 years of experience in solid and hazardous waste monitoring and management. He has designed, developed, and implemented a number of process packages technologies for environmentally sound management of solid and hazardous waste at various industries. He has been assisting various agencies like Ministry of Environment and Forest, Central State Pollution Control Boards, and numerous industries on various issues of solid and hazardous waste management. Sir has more than 25 research publications in reputed national and international journals, edited books, and nearly 60 technical reports, which reflects his broad subject knowledge. He has the credit of having one US patent. He has also been a principal investigator of several projects sponsored by Ministry of Environment, Forest, and Climate Change, which speaks about his dedication and commitment towards his work. Sir is also a technical expert committee member in Central Pollution Control Board, Goa Waste Management Corporation, and Maharashtra Pollution Control Board. Finally, it's our privilege to have you here as a guest speaker for our second session, sir. Welcome you, sir, on behalf of everyone present here. Now the forum is to you, sir.
Okay. Thank you, Dr. Praveen and Dr. Kazimoni for a nice introduction. So I'll be speaking on challenges in solid and hazardous waste management. Actually, there is some mismatch in the title, but you can ignore that. So I thank organizers, that is UGC, HRDC, RTMNU, and Sevadal Mahila Mahavidyalaya Research Academy Nagpur for giving me this opportunity to present my views on challenges in solid and hazardous waste management. Hope my voice is clear to all.
Yes, sir.
Yes, sir.
Okay. Yeah. So in this presentation, I'll cover 4 aspects. First, in the first part of my presentation, we'll see what are the different types and sources of waste. We call it solid waste and hazardous waste, but under solid and hazardous waste, we generate different types of waste. So we'll see what are these waste in the first part. And then we'll see what are the challenges associated with management of this waste, especially what are the environmental concerns associated with management of this waste. Then in the third part, we'll see prevailing rules and regulations under which all these wastes are managed. Hello. Presentation you baad mein yeah. And then we'll see what are the technological interventions, technological options available for management of this waste. So as you know, when we consider any industrial activity, any commercial activity, any domestic activity, where we provide some kind of raw material as an input, we also provide utilities such as air, fuel, water as utility, and we provide some energy. So in this process, in this activity, we get some product or we generate some energy. But at the same time, we also have 3 different types of environmental discharge. So first, environmental discharge is air emission, which is governed under Air Act of 1981. Second environmental discharge is wastewater, which is governed under Wastewater Act 1974. And third environmental discharge from such activity is solid waste. But as we know, we generate different types of solid waste. So depending on the waste, depending on the source, there are multiple rules and regulations for individual solid and hazardous waste. Like for air emission, we have a single act. For wastewater, we have a single act. But for solid waste, we have multiple rules and regulations for management of these wastes. So what are the different types of waste I'm talking about? So first one is hazardous or non-hazardous waste, which is generated from industry. Okay, so industry can generate both hazardous or non-hazardous types of waste. So depending on the regulation, we need to analyze and we need to categorize whether the waste generated by industry, it will fall under hazardous waste or non-hazardous waste. Second major source of waste generation is municipal solid waste. Municipal solid waste, which is typically generated from our household. Day to day, we are generating waste. And then hotels, they also generate significant quantities of municipal solid waste. Commercial establishment. So household, hotels, commercial establishment, they generate municipal solid waste. Third type of solid waste is biomedical waste, which is essentially generated from our hospitals, clinical research labs, etc. Fourth category of waste is e-waste, which is nothing but out of life and unserviceable electronic goods which are generated from our households, which are generated from our commercial activities, which are generated from our industrial activities. Fifth waste, which comes under solid and hazardous waste, is construction and demolition waste. We are doing so many infrastructure projects, we are doing many construction activities. So in this process, a lot of construction and demolition waste is generated. Those who are staying in Nagpur, they may be aware that there's one bridge just opposite to our railway station, which is called design disaster. So it has got so many problems with transport and traffic, everything. So now that bridge is going to be destroyed and demolished. So destruction and demolition of this bridge is likely to generate huge quantity of construction and demolition waste. Next is plastic waste. Plastic waste is generated from our households, like carry bags, milk pouches, toys, and so many things are in the form of plastic waste are generated from our household. Similarly, commercial and industrial activities also generate huge quantities of plastic waste, which mostly contain packing material or various industrial and commercial goods. When their life is over, they are discarded as plastic waste. And last one is battery waste. Battery waste is nothing but electrical and electronic equipments, commercial and generated from commercial and industrial applications. So these are the different types of waste which are generated from our day-to-day household activity, day-to-day commercial and our industrial activity. So all these waste, they have different rules and regulations. Since these are generated from different sources, they have different rules and regulations. So we'll see what are the rules and regulations associated with this waste. So we will see quickly what are these waste. So first one and most dangerous is the hazardous waste. So hazardous waste is a solid, semi-solid or non-aqueous waste which is essentially generated by industry. When we say it is hazardous waste, it has to be from industrial sources. From household also we generate some hazardous waste like batteries, spent batteries, toilet cleaners, various cleaning agents, but the quantity as compared to industrial hazardous waste is very, very less. So hazardous waste is defined by 4 chemical properties. Like if the waste, it may have ignitability. Ignitability means potential of a waste to cause fire. So there is a criteria, like flash point is a criteria which is used to define the ignitability. Suppose the waste has a flash point less than 60 degrees centigrade, then the waste is called ignitable waste and it comes under hazardous waste. Another criteria for hazardous waste is
Sir,
corrosivity.
slides are not changing, sir.
So you're looking, you're seeing which slide now? This slide you have seen different types of waste. This slide you have seen. Okay.
Yes, sir. Yes, sir.
So can you see the next slide now?
Yes, sir. We are
Yeah,
on
this
what
is,
is hazardous waste, sir.
yes, exactly. So I'm discussing this slide now. So, hope everybody is able to see this slide. Okay. Okay, sir. You're seeing this slide? All of you are seeing? Okay.
Yes, sir.
Yes, sir. Yes, sir.
Yeah. So as I told, hazardous waste is a solid, semi-solid, aqueous, non-aqueous liquid waste, which is essentially generated by industry. And hazardous waste is defined by four distinct properties. These properties are ignitability, corrosivity, reactivity, and toxicity. So waste is called ignitable if it has flash point less than 60 degrees centigrade. A waste is called corrosive waste if it has pH less than 2 or more than 12. A waste is called reactive waste if it reacts violently with water or air at standard temperature and pressure. And waste is called toxic waste when it contains toxic heavy metals, pesticides, inorganics, and organics. So if any of the if waste bears any of these characteristics, then it is called hazardous waste. So typical sources of hazardous waste, as I told you, these are from industry. So especially for example, in if you have visited any chemical industry, you will notice that there are many process and reactors and chemical equipments where we put a lot of chemicals as raw material and we get some product. So this could be in a continuous mode or this could be in a batch mode. So during this process, lot of residues are generated. These residues are generated from the process or reactor. So all these residues, they come under hazardous waste. Like many industries, especially pharmaceutical industries, they use solvents, chemical solvents. So once the purpose of the solvent is over, then that solvent is discarded, what we call spent solvents. So this spent solvent also come under hazardous waste. Many industries, whether it is metallurgical industry, whether it is chemical industry, whether it is electronic industry, so all such industries, they have air pollution control equipments such as back filters, electrostatic precipitators, or scrubbers. So the residues arrested by these air pollution control equipments, they also come under hazardous waste. Similarly, many industries have their own effluent treatment plants for treatment of wastewater. So during treatment of this effluent, again we generate some sludge, which is a chemical sludge. So this sludge also comes under hazardous waste. Many times, if our products they are not matching certain specifications, so all such products are discarded. So these discarded products are also they also come under hazardous waste. So at present, based on the inventory done by various regulatory agencies, State Pollution Control Board, it is estimated that India generates about 9.2 million metric tons per annum of hazardous waste. So I have changed my slide. Hope you are able to see this slide. Change slide.
Yes, sir.
Yeah. Yeah. So this is municipal solid waste. Second category of waste is municipal solid waste. So municipal solid waste is a residue generated during our day-to-day domestic activity or from commercial activity like hotels and other commercial activity. So municipal solid waste is also we call rubbish, we also call trash, junk material. But the proper term is municipal solid waste. Okay. And the major sources of municipal solid waste, as you are all aware, is household waste, commercial establishments. During street sweeping, we also generate and collect a lot of waste. Hotels and restaurant, horticulture activities. So all these sources, they generate the waste which comes under municipal solid waste. So it is estimated that at present India generates 1,50,761 metric tons of waste per day. So if you multiply it by 365, you will get the figure for the entire year. So third waste is biomedical waste. Hope you are able to see this slide for biomedical waste.
Yes, sir.
Okay. So biomedical, yeah. Hello, you can see this slide.
Yes, sir.
Yes, sir.
Yes, sir.
Please continue.
Okay. So this third waste is biomedical waste, which means any solid or liquid waste.
We see the municipal solid waste slide, not the biomedical slide.
Okay, let me just check. Now you can see I have changed.
No.
No.
Sir, yes.
Yes.
Slides are changing. What is biomedical
Yes, sir.
waste?
Now we can see.
I think some people are able to see the changing slides. I think some people are not able to see. So I'm not sure what to
Sir,
do.
it is due to network issue, I'm thinking so, sir.
Maybe there's some issue with the bandwidth of different computers from where people have logged in. So it could be due to that. So I think some people are able to see the slides getting changed. I think some are not able to see. So at present, I am at biomedical waste slide. Hope you are, some of you are able to see the biomedical waste slide. Are you able to see what is biomedical waste?
Yes, sir.
Yes, sir. Yes.
Okay. So biomedical waste means any solid and liquid waste which is generated, which gets generated during diagnosis, treatment, and immunization of human beings or animals, or the waste which is generated during a lot of research activities pertaining to human and animal health. So whatever solid or liquid waste is generated from this activity, it comes under biomedical waste. And the common producer generators of biomedical waste include our hospitals, health clinic, nursing homes, and medical research laboratories which are associated with human and animal health. And the types of waste, biomedical waste includes disposable syringes, sharps, glasswares, plastic items like our IV fluids, and there are so many plastic items which are used in a hospital. So all these wastes are discarded. Then anatomical waste like our body parts, and then many items which are contaminated with blood and body fluid. So all these waste, they come under biomedical waste. And it is estimated that at present in India, we generate about 764 metric tons per day of biomedical waste. So I have moved to plastic waste. I hope you are able to see the slide related to plastic waste. Maybe for some of you, it will take some time to see the slide. Some of you who have a good bandwidth, they might be seeing the slide. What is plastic waste? Okay. So the plastic waste is a discarded plastic items which accumulate in our earth environment, and it can adversely affect human and animal life. You can see the picture at the bottom. It's full of different types of plastic waste. This is a common sight. If you visit outskirts of any city or town, you see a lot of dumps, and in these dumps you will see a lot of plastic waste discarded. So common generators of the plastic waste, they include industry. They use a huge packaging material, and huge quantity of this packaging material is discarded as waste, which is a plastic based material. And then commercial establishment and households. So the plastic waste which is discarded, it includes plastic bottles like our PET bottles, plastic bags, plastic films, packaging materials. We have seen during various functions in the marriages, a lot of plastic cutlery is used, plastic plates, plastic spoons, plastic bowls. So a lot of plastic waste is generated from such activities. Then toys, plastic toys, various consumer goods, textiles. So these are all different types of plastic waste which are discarded. from the industrial activities, from commercial activities, and from our household activities. And it is estimated that India generates about 9.4 million metric tons of plastic waste per annum per year. Okay. So e-waste, e-waste is. Hope you are able to see the slide for e-waste.
Yes, sir.
Okay.
Yes, sir.
Yeah. Thank you. So e-waste is nothing but end-of-life electrical and electronic equipments, which is either whole in part, which are discarded as waste by consumers. So consumer could be the household people, consumer could be the commercial establishment people, or it could be the industry. So whatever electronic equipment we use, once the life is over, we discard it as a whole. For example, if the washing machine, if it is no longer, if it cannot be used, it is discarded as a whole. Entire washing machine is discarded, like washing machine, fridge, TV, it is discarded as whole. But sometimes we give it for repairing. So during repairing, for example, someone will say कि इसका PCB गया है, इसको PCB change करना पड़ेगा. So it is repaired, and that part of PCB is discarded. So it could be in the part, it could be discarded as a whole, or it could be discarded in the part. So this is during manufacturing, refurbishment, and repairing process, whatever such waste is generated or discarded, that is e-waste. So common generators of e-waste include industries, commercial, and domestic consumer. And the type of e-waste includes like IT and telecom equipments, TV, refrigerator, washing machine, air conditioner, lamps, industrial control panels. So these are the typical e-waste which are discarded. And it is estimated that about 3.19 million metric tons of e-waste is generated and discarded every year. Okay. Next one is construction and demolition waste. Construction and demolition waste is the waste which is generated from construction, renovation, repairing, demolition of houses, large building structures, roads, bridges, piers, and dams. So during the construction, repairing, or demolition activities, a lot of construction and demolition waste is generated. You can see the picture at the bottom, the type of construction and demolition waste we generate. So the construction and demolition waste, usually it consists of wood, steel, concrete machinery, plaster material, the metal, and asphalt. Sometimes the construction and demolition waste also contains the hazardous material such as asbestos. Like asbestos sheets were used in earlier years for roofing of houses and sheds. So asbestos is a highly hazardous substance, and during such demolition activities, asbestos can get into the construction and demolition waste. Presently, the construction and demolition waste generation amounts to 62 million metric tons per annum. Actually, it is written MSW generation, but it should be C&D, construction and waste demolition, and which is 62 million metric tons per annum of construction and demolition waste is generated in our country. Similarly, battery waste is again end-of-life batteries which are used in various electrical and electronic equipments, consumer products, and vehicles. So once their life is over, the battery is discarded. It is discarded as waste. You may be knowing the discarded battery contains highly hazardous or toxic substances such as sulfuric acid, mercury, nickel, cadmium, lead, as well as other dangerous metal. And it is estimated that about 50,000 metric tons per annum of battery waste is generated at present in India. You can see the picture in the bottom. There are different types of batteries, right from your small pencil cell to different high capacity batteries. So we have seen now what are the different types of waste which are generated. Now we will see what are the challenges associated with management of these different types of waste. Hope you are able to see this slide, challenges associated with waste management.
Yes, sir.
Okay.
Yes, sir.
So when we talk about the challenges associated with this waste, uh, this means we have to see what are the environmental concerns associated with this waste. Why this management of this waste is so important? What happens if we don't handle, if we don't collect properly, and if we don't treat and dispose of our waste properly? What kind of environmental challenges or concerns it can have? So for this, we need to first review the historical waste management practices. What we have been doing with our waste in the past many decades. What has then due to this past waste disposal practices, what environmental concerns, what environmental challenges have occurred? This we need to see this. Then we have to also review what we have been doing at present with our waste. And then based on review of the historical practices, based on the environmental concerns associated with management of this waste, and based on the review of present waste management practices, we can develop proper strategy for future waste management systems. Okay. So if we take a historical waste management, historical review of our waste management practices, this is an example for hazardous waste. I'm discussing historical waste management for hazardous waste. So all of us know the industrial revolution started in India sometimes in 1960 onwards. During this time, we started establishing a lot of petroleum refineries. We started establishing petrochemical complexes. We had many fertilizer industries. During this time, we developed our steel plants and smelters for various non-ferrous industry. This means 1960 onwards, as I told you in the beginning, any industrial activity where we provide some input, some utility and some energy, we get product, as well as along with the product, we generate waste, different types of waste also. So during 1960s, when we started developing our industries, at that time itself, we started generating huge quantities of hazardous waste. So, but although we started generating hazardous waste, but that time there were no rules and regulations available for safe disposal of this waste. So first legislation on hazardous waste, it came into existence in 1989. Okay, but before that, before 1989, there was no regulation. So whatever waste were generated by the industries, even for that matter, whatever the waste generated from our household activities, different types of waste like e-waste and different types of waste, they were simply dumped on the land. Okay, because there was no system available, there was no concept available for waste management before 1989. Even after having the regulation in 1989, there was no infrastructure available for handling and disposal of this waste. So it continued till year 2003. So right from 1960s, when we started developing our industries up to the year 2003, we simply dumped our waste on open land, resulting in contamination of various components of environment, such as air, groundwater, soil. So this resulted in open and illegal dumping of waste till year 2003. So as of now, there are more than 300 hazardous waste contaminated sites existing in India, which is having huge quantities of hazardous waste containing all kinds of toxic metals, all kinds of toxic organics and inorganics, which are leaching into the groundwater, which are contaminating the soil, which are releasing to the air and contaminating the air. So right now, there are 300 such sites which are distributed across the entire country, especially in the industrial areas, industrial belts like Gujarat, Maharashtra, Andhra Pradesh, Telangana, Tamil Nadu, West Bengal. So all such sites are distributed throughout India, where it is predominantly the areas having the large number of industries. So all such areas, they are occupying thousands of hectares of land, and they are containing millions of tons of waste at this site. So obviously, because of unscientific and illegal disposal, it resulted in several environmental impacts. Like they release dust and volatile emissions from these sites. During monsoon season, when the rain falls on these dumps, the hazardous constituents present in the waste, they get into the surface runoff, and the surface runoff, when it migrates and reaches to a nearby water body, like our lakes, rivers, it contaminates those water bodies. Similarly, the hazardous constituent, they also get leached with the rainwater. They percolate our soil strata and they reach the groundwater, and they also result in contamination of groundwater. So if we look at our historical waste management practices, we see that we have not done our waste management properly, and it has resulted in contamination of air, it has resulted in contamination of surface water, it has resulted in contamination soil and groundwater. So unscientific disposal of waste has resulted into contamination of these resources. So you can see this picture, environmental risk due to unscientific disposal of waste.
Yes, sir.
Yeah, so just see there's a waste dump there. Since the waste contains a lot of organics which are airborne, if it contains dry waste, then the dust. So all these organics and dust, they get emitted from the dump site. It get transported with air, and if the air gets contaminated, and if there is if there are some residents staying in the downstream of the wind direction, so they will get exposed to all kinds of hazardous constituent which are released from the dumps. Similarly, you can see the surface runoff carrying hazardous constituents from these dumps. They get to the nearby water bodies such as lakes and river, and they contaminate it. And you can see there is a yellow patch in the bottom. So this is all hazardous constituents which have been leached from the dump during monsoon season, because when the rain falls on the waste during monsoon season, many of the hazardous constituents which are present in the waste, they are highly solubilized in water. So they will when the rain falls on that, they get solubilized, and this rain percolates the subsurface soil strata, and ultimately it reaches the groundwater. So in the entire groundwater can get contaminated. And if there are people staying in the downstream area, and if they are using this groundwater for various activities, for like drinking and other domestic activities, so they'll be all exposed to the hazardous constituent present in such groundwater. So in general, if we look at the environmental risk due to unscientific disposal of waste, we see that it leads to air pollution, it leads to surface water contamination, it leads to groundwater contamination and soil contamination. These are some of real life pictures related to how the hazardous waste were disposed of in the past. You can see these pictures. Hope you are able to see these pictures.
Yes, sir.
Yeah. So you can see there is a picture in the top with some water body. There are 3 layers. First layer is dark brown color. Second layer is reddish color, and third one is water. So the first layer is a hazardous waste containing hexavalent chromium, waste containing hexavalent chromium. So industry disposed of almost 2 lakh tons of such hazardous waste on open land. The waste contains hexavalent chromium, which is highly solubilized in water, and this site, it is in existence for past 3 to 4 decades. But today also, if we visit the site, you can see hexavalent chromium getting leached into the groundwater. It is getting leached into the soil. It is getting leached into the surface water. There are other pictures. You can see those drums. These drums contains highly toxic spent solvents and organic waste, which were disposed of by the industry unscientifically and illegally. At the bottom, you can see there's a picture. There are a lot of waste which is dumped along the highway. Mostly during those years, initial years, when the rules and regulations were not existing, when the rules and regulations were not effective, the industry used to simply throw their waste on the roadside. During night time, they'll throw the waste and they'll run away. So there are many such areas, many such sites where such hazardous waste is lying unattended. In the right side, you can see there's a picture with some cattle sitting in the water body, and you can see some yellow patches. So this yellow patch is hexavalent chromium again. It is actually a hazardous waste dump containing hexavalent chromium. This site is located in Kanpur, near Kanpur, Rania, in Kanpur, Dehat. So huge quantities of this waste were disposed of by the industry, and the local authorities, they constructed a road on that. But after few years, the hexavalent chromium started leaking, releasing from this site, and it contaminated the water body. You can see the water body is contaminated with hexavalent chromium, and a lot of cattle is sitting there, and they are getting exposed to hazardous to hexavalent chromium. You may be aware that hexavalent chromium is a known carcinogenic substance. Okay. So like this, I have seen some representative pictures. Like this, there are more than 300 such hazardous waste contaminated sites where millions of tons of hazardous waste are still existing almost for past 5 decades. So situation is very alarming regarding this waste. Although 5 decades have elapsed, but we are not able to manage this waste properly till today. This is because once the site is contaminated, it requires a lot of time as well as a lot of money to get it remediated. So each site, if you want to remediate, it will take about 200 to 300 crore rupees, depending on the extent of contamination. You can see this slide. I have changed my slide with some fire and some bottles.
Yes,
You're
sir.
able to see this?
Yes, sir.
Okay, so just see the picture on the top. There was a huge fire and explosion because of unscientific disposal, unscientific storage and disposal of the waste containing spent solvents and organic substances. These waste were stored by some industry in open in a shade, and the waste was highly volatile, and the vapors got released from this waste, and there was some kind of spark, and because of the spark there was a huge explosion, and there was a massive fire. There are many such incidences of fire and explosion due to unscientific storage, handling, and disposal of such hazardous waste. On the right side, you can see there is an open well. There is an open well, and you can see some samples of the groundwater collected from this open well. Hope you are able to see the yellow color of the sample and yellow color from the well. So this is a well which is located downstream of the industry. I told you about industry disposing of huge quantities of waste containing hexavalent chromium. So over a period of time, hexavalent chromium has leached from leached from this site, and it has contaminated about 1 kilometer by 1 kilometer area in terms of groundwater contamination. So we carried out the studies at this site, and we collected the groundwater samples from all the affected wells, and we found you can see the color of groundwater there. It looks like pineapple juice, yellow color. So this yellow color is due to the presence of hexavalent chromium. The concentration of hexavalent chromium present in this waste, in this water, groundwater, it was almost 214 milligrams per liter. Just imagine hexavalent chromium, which is a known hazard, known carcinogenic substance. the concentration of hexavalent chromium was 214 milligram per liter in the groundwater, whereas the permissible limit is 0.01 milligram per liter. So you can just imagine what kind of environmental impact can cause due to unscientific disposal of this waste. You can see the picture in the bottom. You can see we are trying to collect the groundwater from one of the affected area. You can see the color of groundwater here. It is looking just like Coca-Cola. So this water, the groundwater is contaminated due to the waste disposed unscientifically by industry, which was producing H acid. H acid is a dye intermediate which is used in preparation of various dyes. So during the production of H acid, huge quantities of hazardous waste were generated, but industry simply disposed it of this waste on open land in underground tanks. We started releasing the hazardous constituent, and it contaminated the groundwater in the entire area. You can see the color of water which is collected in the water. It's all looking just like Coca-Cola. You can see the another picture on the right side, how the land is getting contaminated. You can see the vegetation getting burned, getting damaged because of direct disposal of such waste on open land. So these are some of the examples of environmental impact. What kind of environmental impact we can it can cause when we dispose of our waste unscientifically. So we have seen environmental concerns associated with hazardous waste. Now just see the environmental concerns associated with plastic waste. You can see these pictures. You can see this slide, environmental concern associated with plastic waste.
Yes, sir.
Yeah. So you can, so this is a common sight when we visit any city outskirts of the city. There is a area where entire quantity of city's waste is disposed of. So it contains a lot of plastic waste. We often see there is a fire at such plastic waste. Many times the plastic, many of these plastic, they contains toxic substances also, like PVC. PVC is a polyvinyl chloride. So when we burn polyvinyl chloride unscientifically, it results in formation of dioxins and furans, which are extremely toxic substances, which get generated due to such unscientific burning of plastic. You can see the cattle grazing on the plastic on these plastic dumps. So normally whatever leftover food is remaining, we just collect it in a plastic bag and we dispose it of. And then this plastic bag containing leftover food, it reaches such dumping site. So the cattle, they come in search of food, and they'll eat the plastic also along with the leftover food. You can see at the bottom a lot of plastic waste is getting accumulated in the water body. Every year we see especially during monsoon, lot of flooding occurs in urban areas. So this flooding is mainly due to like whatever plastic waste we discard. Ultimately, they reach our drainage areas. They choke the drainage, especially those panni, we call panni, or the plastic bags less than 50 microns. We have seen many small plastic items which are used for gutka. So all these plastic waste, they reach the our drainage, they choke the drainage, and since there is no drainage of water, every monsoon we see a lot of flooding occurring in the urban areas. And also ultimately when we discard this plastic waste, they get carried from our urban areas to a nearby river, and ultimately the river when it reaches the ocean, all the plastic waste it gets carried to the ocean. So the environmental concerns associated with plastic waste include unaesthetic look, soil pollution, since we are putting the waste directly on soil. It can contaminate, it can pollute air due to open burning. It can contaminate water bodies. and has adverse human and animal health impacts due to inhalation and ingestion of harmful gases, as well as they get into our body through various exposure routes. Now we are seeing environmental concerns associated with municipal solid waste. Again, this is similar to the plastic waste. We see a lot of dumps of municipal solid waste around our cities, especially during monsoon and especially during summer season. There's a lot of foul smell emanating from such municipal solid waste dumps. Again, many times there are fires associated with unscientific disposal of municipal solid waste. It can contaminate the soil. It can contaminate the surface water. Again, similar to hazardous waste, it can contaminate the groundwater also. So, municipal solid waste has similar impacts to hazardous waste. It can contaminate it. It can contaminate soil. It can contaminate contaminate air, contaminated water sources, and also has adverse effect on human and animal life. One more impact due to this unscientific disposal of municipal solid waste is GHG emission, which is responsible for global warming. Since the municipal solid waste contains a lot of organic fraction, and when we dump this municipal solid waste, we go on stacking. Due to anaerobic activities, the organic material present in the municipal solid waste, it gets converted to methane, and there are huge quantities of methanes are released to the atmosphere from such municipal solid waste dumps. And also, if if the concentration of methane is high, and if there is a source of fire, source of ignitions, a lot of fire incidences have also happened on such municipal solid waste dumps. So we have seen different types of waste generated, and what are the challenges or what are the environmental concerns associated with this waste, whether it is hazardous waste, whether it is municipal solid waste, whether it is e-waste, any waste, whether it is plastic waste. If we don't manage our waste properly, it is going to have adverse impact on air, water, soil, and groundwater, and ultimately it will affect the human and animal life, human and animal health. So now just look at the present waste management systems, how we are managing. We have seen how the waste were managed in the past and what kind of environmental impacts it has resulted. Now we'll see the present waste management system. So again, if we take an example of hazardous waste, at present we generate 9.2 million metric tons of hazardous waste per year. Out of these 9.2 million metric tons of hazardous waste, only 50 to 55% waste is either reused or recycled. Just see the quantum of waste generated, 9.2 million metric tons, out of which only 50% is reused and recycled. And only 4 to 8% is incinerated. Incineration is nothing but controlled burning. And almost remaining 40 to 45% of the waste is disposed of on land. So these are all scientifically designed landfills. But the problem is, when you dispose of such a huge quantity of waste, it requires a lot of area for disposal. So it is estimated that area required for disposal of such a huge quantity of hazardous waste is more than 45 hectares per year. 45 hectares per year, you can see the area required. Since land is a scarce resource, we don't have enough land. And if we go on dumping, if we go on disposing this waste on the land, at some point of time, we won't have any land for disposal. So these are the issues associated with present waste management system. Only 50% is reused, and almost 40 to 45% is disposed of on land. So it requires some interventions where we need to maximize the reuse and recycle and minimize the land disposal. Okay, now we have seen different types of waste, and I told you in the beginning, each waste depending on the source, we have different rules and regulation. So for hazardous waste, uh, actually the first legislation on hazardous waste was notified in 1989, but it was observed that those rules were not very effective. So all these rules, they are frequently amended depending on their implementation, depending on the outcome of these rules. They are frequently amended. So for industrial waste, whether it's hazardous or non-hazardous, we have hazardous and other waste management and transboundary movement rule. So latest rule was notified in the year 2016. Similarly, for municipal solid waste, we have solid waste management rules. Again, these rules were amended in 2016. For biomedical waste, we have a separate rule called biomedical waste management and handling rule. Again, it was amended in 2016. Similarly, for e-waste, we have a separate rule called e-waste management and handling rules, 2016. For construction and demolition waste, we have a separate rule called construction and demolition waste management rule. Plastic waste, we have a separate rule, plastic waste management rule. Similarly, for battery waste, we have battery waste management rule. So all these rules and regulations were notified in different period of time, but they undergo frequent amendment. So a major amendment was made to all these rules. That's why we can see all the rules were amended in 2016. Battery waste was again further amended in 2022. So if we look at all these rules and regulations, the text of these rules and regulation is available on internet. Anybody who is interested to know further details regarding these rules, they can download these rules and regulations from the sites of Ministry of Environment and Forest and Climate Change. They have notified all these rules and regulations on their sites. You can just simply download these rules and you can read. But just to put a summary of these rules, uh, these rules provide definitions of the waste, applicability of these rules, applicability of this waste, like for example, municipal waste. Municipal waste are applicable to whom? Solid waste, hazardous waste are applicable to whom? So the text of these rules provide definitions, applicability, and there are different schedules, different lists. These rules also list the roles and responsibility of the manufacturer, roles and responsibility of the waste generator, the regulatory agencies, and waste managers. For example, if I'm dealing with hazardous waste, so hazardous waste is generated by the industry. So the rules will provide the responsibility of the industry, how the industry has to collect their waste, how the industry has to segregate their waste, and how the industry has to store their waste. Then what kind of permissions are required for handling, storage, and disposal of this waste? That will have the responsibilities of the regulatory agency. Like a regulatory agency need to issue the consent, they need to issue the authorization to the industry. So all the roles and responsibilities of the regulatory agencies are also defined in these rules. Like once the waste are generated, it is taken by the private parties for disposal. So what should be the roles and responsibilities of the private parties who are dealing with the waste transportation and waste disposal? It is given in these rules. And these rules refer various guidelines which are available for reuse, recycle, treatment, and disposal, which are developed by the Central Pollution Control Board. And also there are different forms and permits which are required for these rules. So this is just a summary. If you are interested, you can just download these rules and you can go through the detailed text of these rules. This is an example of again regulation on hazardous waste. The hazardous waste and other waste management transboundary movement rule, which was last amended in 2016. So as per these rules, there are total 8 schedules. The schedule 1 lists 38 industrial processes which likely to generate hazardous waste. So all kind of industries which are existing in India, these are listed there. and what kind of hazardous waste is generated from these 38 industrial processes. It is also listed. Then there is Schedule 2. Schedule 2, it is again divided in Class A, Class B, and Class C. So the Schedule 2 provides the leachable concentration of the hazardous constituent in the waste. For example, I am an industry. I generate say 10 tons of some waste, and for example, I generate 10 tons of ETP waste. So if my ETP waste contains say more than 50 milligrams of say cyanide, this becomes hazardous waste. If it contains say 20 milligram of 20 milligram of leachable concentration of mercury, then it becomes hazardous waste. So like this, there are Class A, Class B, and Class C, which provide different concentration limits for various hazardous constituent. Then there is Schedule 3, which deals with the hazardous waste which are either imported or exported. A lot of wastes are imported and exported for reuse, recycle, treatment, and disposal. Similarly, Schedule 4 lists commonly recyclable hazardous waste. Schedule 5 gives specification for recycling of used oil, used waste. So like this, there are different 8 schedules which give different criteria, different aspects, different list, different concentrations of hazardous waste. This is an example of Schedule 1 of Hazardous Waste Rule 2016. You can see, hope you are able to see this slide. Schedule 1 HWM
Yes,
Rule
sir.
2016.
Yes, sir.
Okay. So you can see the first column, there is an industrial process, for example, petrochemical process and pyrolytic operations. So if the industry falls under this category, petrochemical industry, there are 9 types of hazardous waste generated from this activity. So like this, total 38 industrial operations, 38 industrial processes have been listed in Schedule 1. So you can see if you are studying any industry, suppose it is say a petroleum refinery. So the petroleum refinery will generate oily sludge emulsion. It will generate spent catalyst. It can generate spent slope oil. It can generate organic residue. It can generate chemical sludge from ETP. So it is very well defined what kind of hazardous waste are generated from the different activities. This is an example of Schedule 2. I told about a different concentration of hazardous constituent present in the waste. Suppose I generate a waste, and if it contains say 5 milligram per liter leachable concentration of arsenic in the waste, then my waste becomes hazardous waste. So like this, there are almost 46 parameters which are listed. So we have to see whether the waste contains any of these parameters. If it contains any of the parameters, then the waste is categorized as hazardous waste. So these were the examples how the different rules and regulations available for different types of waste. Now we'll see what kind of technological interventions are required for management of this waste. So this is a typical hierarchy. This is a system, technological interventions which are required for waste management. Are you able to see this slide? Technological interventions for waste management. You're able to see?
Yes,
Yes,
sir.
sir.
Yeah. So the options are listed in the order of desirability. For example, if you want to have the best waste management practice, we should avoid generation of the waste. This is the most accepted option for waste management. But many times it may not be possible to avoid the generation of the waste. So in this case, okay, I'm not able to avoid generation of waste. I will generate some waste. Then we have to see whether you can minimize this waste generation. Suppose I'm having an industry. I'm generating at present say 500 tons of waste per year. So whether I can bring it down from 500 tons per year to say 50 tons per year or 100 tons per year, and what are the options available for minimizing the waste, I need to do this study. Okay, but sometimes it may not be possible to minimize the waste. Okay, I am generating at present say 1,000 tons per year. I may be able to reduce it from 1,000 tons per year to say 600 or 700 tons per year. Okay, but still this 600, 700 tons, I need to manage this waste. So the third option is to see whether whatever waste is still generated, whether you can recover value-added materials from this waste, whether this waste is recycled in the same process, whether it can be reused and recycled in some other process, that we need to study. So recovery, reuse, recycle is the third option.
Mahedra, your voice is not clear. Hello. Hello, Dr. Mahedra. माझा आवाज जात नाही त्यांना. चॅट मध्ये काय लिहू?
One is burning and another is land disposal. So burning, we call it incineration, and if incineration is not possible, then the last option is to dispose of the waste. So these are the technological options available for safe and scientific management of any of the waste, whether you take it hazardous waste, whether you take it municipal waste, whether you take it e-waste, plastic waste. So this is a typical management hierarchy used for any kind of waste. So we'll see what are the examples. You can, this is this slide, the option was option 1, avoid waste generation. You can see this slide.
Yes, sir.
Yeah,
It is visible, sir.
yeah. So this is just an example. I'm showing the example. When I we have seen in the previous slide, the option was to avoid waste. So here an example, this is for caustic soda industry. Caustic soda, you might be aware, previously the process used for caustic soda process was mercury cell process. In this process, mercury was used as one of the raw material. So whatever waste or sludge was generated from mercury soda process, it used to contain a lot of mercury. So it was a hazardous waste. But then a lot of research was done and an alternative process was developed. This is called membrane cell process. So in the membrane cell process, mercury is not used. So the sludge generated from this membrane cell process is not a hazardous waste. So simply by changing from one process to another process, we have avoided the waste generation. Nowadays, the membrane cell process, they don't generate mercury sludge. So what I mean to say is, if we go for cleaner and greener production processes, we can avoid waste generation. So a lot of, you might have heard the term green chemistry. Green chemistry is a process to manufacture any product without generating any secondary pollutant such as hazardous waste. So this is an example of how we can avoid waste generation, that is by simply going for cleaner and greener production process. Option 2, we have seen waste minimization. It is always not possible to avoid waste generation. So water waste is generated, whether we can minimize waste. So there are different options available for waste minimization. We can go for process and equipment modification. Suppose I am operating the industry. If I use very inferior quality process equipment, if I use very old equipment which are not properly repaired or managed, so it will not have very good production efficiency. So with such process and equipment modification, we can increase the production efficiency. And once we increase the production efficiency, obviously the waste will get waste generation will reduce. So this is one option. By going for process modifications, we can minimize the waste. Similarly, for going good quality raw material, we can minimize the waste. Suppose metallurgical industry, they use some metal ore. So metal ore, it will contain say 30-40% of the metal and 60 to 70% of the gang material. If I process this ore, and when I get the metal as a product, at the same time 60 to 70% of the material which is discarded as a waste. But if I go for a better quality raw material, for example, if I use say raw material which is having 60% metal content and 40% gang material, so my waste, if I use a good quality raw material, my waste generation will reduce. So this is another example of waste minimization. Third option for waste minimization is good housekeeping. Normally we have seen whatever waste is generated. For example, in our household also, we generate paper, plastic, glass bottle, we generate our kitchen leftover waste. Normally we put everything mixed together and then discard. So once everything is mixed together, then you cannot do any reuse, recycling, and it's very difficult. So with good housekeeping, if you do proper segregation, if you are having an industry, if you avoid leakages, spillages, and if you avoid mixing, then if you segregate all your waste, then it has a very good potential for reuse, recycle, and the waste for disposal will be very less. So with these options, you can do the waste minimization. See, this is a typical picture. You can see the picture here. If you visit any industry and if you visit their backyard, you will see the common area where everything is discarded and dumped by the industry. So it will contain paper, plastic, metal drums, sludges, everything. So if you mix together, then nothing is possible. Its management is very difficult. But if you do proper segregation, then most of the things you are able to reuse and recycle, and only a small quantity will go for disposal. So through proper collection, segregation, and storage, you can do waste minimization. Third option is recovery and recycle and reuse. As I told you, some waste is likely to generate, and you're not able to minimize the waste 100%. So whatever waste is generated, we have to see whether this can be reused, recycled, or recovered for any purpose. So there are two options. One option is on-site recycling. On-site recycling paper, plastic, kitchen waste, everything. If we do proper segregation, we can recycle the paper, we can give paper to the Raddiwala, we get some revenue. If we segregate the plastic and glass bottle, if you give it to the Kabadiwala, he will give you some money. Similarly, if you do proper segregation, it will help you to recover, recycle, and reuse the waste. So this is on-site recycling. The same thing applies for industry. The waste generated by the industry, it could be utilized in some other process of the same industry. So that is called on-site recycling. But if it is not possible to recycle it on-site, we call it off-site recycling. Like we have to give waste to some other industry. Like for example, I generate some waste which may not be a raw material for my industry, but it could be a raw material for other industry. For example, I generate some waste fuel. I don't need waste fuel, but there is an industry, for example, cement industry. Cement industry needs a lot of fuel. So they can take this waste fuel from me as a raw material for their industry. So that is called off-site recycling. Nowadays, the government of India is also promoting circular economy. The purpose of circular economy is to minimize or eliminate the land disposal of waste. So during various activities, whether it is domestic activity, whether it is commercial activity, whether it is industrial activity, whatever waste is generated, it should be such that it should get reused, recycled 100%. There should not be any waste for disposal. This is called circular economy, which is being promoted aggressively by the government of India. Option 4, as per the hierarchy, is waste treatment. When the waste is it cannot be reused, recycled, it has to be treated and disposed of. So there are different options available, like physical treatment, chemical treatment, and biological treatment. By using physical treatment, you can reduce the waste volume. So you can go for solid liquid separation technologies, filtration, centrifugation. Different technologies are available. Many times the waste contains toxic substances like heavy metals. So before disposing of this waste, you need to treat this waste chemically to reduce their toxicity. Suppose the waste contains, say, arsenic in trivalent form. Arsenic in trivalent form is highly toxic, highly soluble. So if you go for some oxidation process, you can convert it to arsenic pentoxide. Arsenic pentoxide is relatively more stable, less soluble, and less toxic. Third is biological treatment. Many times the waste contains organic substances which can be degraded by the consortium of microorganisms. The examples of biological treatment like the waste generated from petroleum refineries, waste generated from pharmaceutical industries, they contain a lot of organic. So you can just develop and use a consortium of microorganisms for degradation of the hazardous constituent present in the waste. So with the physical, chemical, and biological treatment, the waste can then be disposed of in a controlled manner. This is the fifth option. That is the last option, which we call ultimate and final waste disposal option. So there are two systems available, two technologies available for ultimate disposal. Like suppose if we consider human beings, when a human being dies, we either cremate him. If you visited crematoria, we either burn him, or depending on the religion, if Hindu people will burn him, Muslim people will go for जिसमें हम कहते हैं कि उनको दफनाते हैं. तो इसी तरह से फॉर वेस्ट ऑल्सो वी हैव टू अल्टीमेट सिस्टम. आइदर जो कुछ रेसिड्यू, फाइनल रेसिड्यू वेस्ट का बचेगा, we have to either incinerate that or we have to dispose it off in a secure landfill. So incineration is nothing but combustion in a controlled manner. So incineration is suitable for waste having some calorific value. For example, if the waste has calorific value more than 2500 kilocalories per kg, we can go for incineration. But many times the waste which are suitable for incineration, they include waste containing oil, oily sludges, spent solvents, tarry residues, pesticides, spent carbon, process residues containing organic. So these are all suitable for incineration. If such waste are not cannot be reused, recycled, it has to be disposed of through incineration. And if nothing is possible, if you cannot incinerate, ultimately it has to be disposed of in a secure landfill. So secure landfill is disposal in land where you have to design and develop a secure landfill system containing different layers of flexible membrane liner, which do not allow percolation of leachate or movement of the hazardous constituent to the surrounding environment. So the secure landfills are suitable for the waste which are inorganic in nature, which are metal based, which cannot be reused, recycled, or incinerated. And the examples include the ATP sludge, process residue from metallurgical industries, spent acid, alkalis. So all such waste, if they do not have any use, it has to be disposed of in landfill. So this is an example of incineration, which is a combustion system where there are many centralized incineration systems operating in India. They use mostly rotary kiln kind of incinerator, where the waste metals are feed at the one end. Temperature is maintained at 850 to 1000 degrees centigrade. The gases which are generated during this combustion, they are further incinerated or further combusted. They are treated through various air pollution control equipments and discharged to the environment. And whatever ash is generated in the process, this ash is collected and it is disposed of in secure landfill. So finally, the secure landfill is a containment system which is designed and constructed to contain the waste so as to minimize release of contaminant to the environment. So before putting the waste in the landfill, as I told you, it has to be treated like chemically. We need to solidify and stabilize this waste. And there are guidelines given by Central Pollution Control Board how the hazardous waste incinerator should be designed and operated, how the secure landfill systems are designed and operated. So CPCB has given the guidelines for design of these systems. So this is an example of hazardous waste secure landfill system. There is a bottom liner system. We call it composite liner system. Before the waste is disposed of, we need to select the site which can be developed into a secure landfill. The area is excavated, and then there are different layers of liners. Like first, we have a clay liner, 150 centimeter clay liner is placed. Above that, we use a HDP liner of 1.5 mm thickness. Above that, we need to provide a leachate collection system. And then there is another set of clay liner, synthetic liner. So it is a very, very secured system. This liner system is placed, and then we start disposing of the waste. So each landfill has a capacity. It is designed for say 20 years, 25 years. So once you construct the landfill, you go on putting the waste for 20 to 25 years. When its capacity is over, then it has to be finally covered. So again, for covering, we have this liner system. We placed a clay liner, we put synthetic liner, we put a drainage layer, and finally we place a vegetative cover. You can see the picture at the bottom. This is from one of the secure landfill facility. It looks like a recreational area. It looks like a garden. So you can below this there is all it is all containing the highly toxic hazardous waste which is stabilized and disposed of, over which we have the facility has grown the lawn. This can be used for recreational purpose. So this is the last option for any waste management, for any waste management. So this some of the pictures how the secure landfill is constructed. Similarly, the options for municipal waste management we have seen for solid waste, hazardous waste. Now these are the treatment options for municipal solid waste. Again, if you want to do a proper management of municipal solid waste, waste has to be properly collected, segregated, so that it can be recycled to the maximum extent. This is valid for the dry fraction like paper, plastic, glass, metal. It can be collected, segregated, and recycled. The second fraction of the municipal solid waste is our leftover food. We call it wet waste. So this wet waste can be subjected to anaerobic digestion. You can generate methane, and this methane can be used as a source of energy. It can be used for producing power. So this is second option for municipal solid waste management. Third option is thermal treatment, like incineration. Whatever waste is generated, mixed waste, you subject it to thermal treatment at 850 to 900,000 degrees centigrade. And if you generate some energy, this energy can be recovered and it can be utilized for generating power. So these are the options for municipal solid waste management. So there is a NIRI is associated with management of municipal solid waste in Goa. So we are working as an expert agency to them, and we have helped them to design and construct a plant for management of municipal solid waste. As of now, this is one of the best plant existing in country for municipal solid waste management. So the waste are collected by the local municipal corporations, panchayat. The waste are there's a lot of awareness in Goa, residents in Goa. Government of Goa have raised various awareness programs, and people, they are collecting their waste in two different fraction, dry waste and wet waste, and it is collected and transported in a different fraction, dry waste and wet waste. It comes to this plant. This plant is designed for a capacity of 250. There are two plants. One is 250 tons per day, other is 100 tons per day. Here, whatever dry fractions are received, they are again further segregated in 10 fractions: paper, plastic, metal, and so it is segregated in different fractions, and it is reused, recycled to the maximum possible extent. And the wet waste here is converted to biogas, and they have a captive electricity production using this biogas. And whatever after biogas generation, whatever residue is generated, this residue is converted to compost. So if you happen to visit Goa, and if you are interested, you can visit this plant. This will give you how the waste is managed, municipal solid waste managed in a safe and scientific, environmentally scientific manner. So this is worth visiting the plant. You can, if anybody is interested, I can facilitate visit to this plant. Similarly, for treatment options for biomedical waste, you can go for autoclave, we can go for microwave, we can go for chemical disinfection, and ultimately whatever residue like anatomical waste is there, plastic waste is there, there's no option for reuse recycle. It has to be discarded through incineration. Incineration is the ultimate option for biomedical waste. Similarly, for plastic waste, the option should be, first we have to reduce the generation of plastic waste. Then whatever plastic waste is generated, we have to reuse, recycle, we have to recover, and only a small fraction which you cannot do anything, only that fraction can go to landfill. But ultimately, landfilling of plastic waste is to be avoided. It has to be reused, reduced, reused, recycled, and recovered. Okay. Similarly, for technologies for e-waste management, there are different methods available: physical methods, chemical method, thermal method. Here also, you can dismantle the e-waste, segregate into different fraction, and you can go for recycling. And if you want to recover some value-added material, you can go for chemical treatment. You can go for leaching for recovery of precious metals. E-waste contains a lot of precious metals such as gold, germanium, silver. So through such chemical methods, you can recover those precious metals. There are also thermal methods available for pyrolysis gas, for generation of gaseous and liquid fuels, and any residue like plastic residues and all, you need to go for incineration. So this is how the waste can be managed. As far as NIRI is concerned, we have been working in the solid and hazardous waste management for almost for past 35 years. We deal with municipal solid waste, hazardous waste, biomedical waste, all kind of waste we are dealing. We do basic and applied R&D. We have a very good teams of chemical engineer, environmental engineer, mechanical engineers, biologists. So we have various tools and softwares also available. We have a very good laboratory available with us, analytical facility. So with this infrastructure, with the skill and highly qualified manpower, we are dealing with this waste for past 3 decades. We have done more than 100 projects for various issues of solid and hazardous waste management. And in this process, we provide our services for waste inventory, waste audit, waste treatment, waste minimization, reuse and recycle, environmentally sound management, remediation of the contaminated site. We also conduct a lot of trainings and capacity building programs. If you visit our website, a calendar of all such training programs is available. So if anybody, any one of you, if you are interested, you can avail our services for any of the activities. Okay. These are some of the significant projects we have done in the past. This one is full-scale treatment and disposal of arsenic waste. Here we have disposed of almost 700 tons of highly toxic, highly hazardous arsenic waste at Zuari Industry, Goa. Right now, we are doing a full-scale remediation project for mercury contaminated site at Kodai Canal. We have done one project recently at Hindalco, Cochin, where the hazardous waste generated by the industry has been safely collected and disposed of. We are also doing many projects for municipal solid waste like biomining, treatment, disposal. So these are some of the projects we have done in the recent past. So with this brief overview on different types of waste, I'll stop here. I thank you all for your attention. If you have any query, just let me know. I can answer whatever time is available. Now I can address few queries. Otherwise, you can also write to me and get back to me, and I can help to resolve your queries. Thank you. Thank you very much. Over to the organizers.
A participant, anybody would like to ask a question?
How you can dispose glass waste at home, sir, at house?
Pardon?
How to dispose glass waste, sir?
Glass
Local
waste.
glass waste. Yes, how to
Glass.
dispose?
Glass.
Yes, sir.
See, glass. You should not dispose the glass waste, because see, glass. If you see the time of disposal, it will run into thousands of years. If you dispose glass, it will remain at the site for thousands of years. So as far as possible, best way is to collect and recycle. You can melt the glass and get some other item produced from this glass. So it is not. Pardon? Hello. So glass should not be disposed of. It has to be collected and recycled, reused and recycled.
Sir,
Yeah.
the landfill method, it has and deep well disposable is also there for the hazardous waste management.
Yeah.
And I also read about the bedrock disposable. So how these methods are effective in hazardous waste management, sir?
See, landfill, when we say landfill, it has to be a secured landfill. And when we say secured, it has to be, I told you in the last few slides, there are different layers of liners. Like if I want to dispose of my waste on land, I need to excavate the area to some extent. While excavating, we need to keep in mind that there should be a minimum 2 meters distance between my groundwater table. For example, my groundwater table at that area is say at 5 meter. Then I can excavate only for 3 meters. 2 meter I need to leave. So this 3 meter I will excavate. Then I will put different layers of. First I will put a clay layer of 150 centimeter thick clay layer, which has a permeability less than 1 into 10 to the power minus 9 permeability. Over that, we place 1.5 mm thick HDPE liner. Above that, there will be a drainage layer, and over that, then I put my waste. So there should not be any release of hazardous constituent from the waste to the groundwater, because there are multiple barriers I am constructing at that site. So whatever hazardous constituent is present, that will get collected through the leachate in the leachate collection system. This leachate we need to pump out regularly, and it has to be treated and disposed of. So if you design your system properly, there will not be any release of hazardous constituent to either soil or the groundwater at that area. This is one thing. Second thing, you talked about bedrock disposal. So bedrock disposal actually is not practiced for hazardous waste. It is normally practiced for radioactive waste, because radioactive waste it is governed by Department of Atomic Energy, and since radioactive waste is a highly hazardous, it is disposed of in the bedrock much at a depth where it will not have any radiation to the surrounding environment. But as far as secure landfill system, they are quite safe. But only the waste which you cannot do anything, whether you cannot incinerate, you cannot reuse, recycle, only such wastes are disposed of in secure landfill. Hope I was able to answer your query.
Yes, sir. Thank you, sir.
Yeah. Any
Sir, I
other?
have questions.
Yeah.
Sir,
So do you think that green chemistry approach should be implemented in every industries, because most of the industries are not following their green chemistry approaches?
Yeah. See, if you want to minimize your waste, if you want to avoid generation of the waste, then definitely green chemistry approach should be followed. But usually it is not possible for industry to go for this green chemistry. But institutions, there are institutions who are doing a lot of such work on green chemistry. And based on this green chemistry, if you are able to develop alternate process to a conventional process, and if you are in the process, if you are avoiding waste generation, then definitely all the industries should switch over to the green chemistry. Because, for example, if you go ahead with the conventional treatment, and in the process, see, if you generate say 500 tons of waste in a month, so if you
Yes, sir.
consider the cost of disposal of this waste, you need to pay at least 5,000 to 10,000 rupees per ton to the agency who is taking care of your waste. So in the process, you will lose a lot of money. But if you switch over to the greener chemistry process, initial investment will be high, but in the long term, you will be saving lot of money on the waste treatment. So definitely, as far as possible, wherever possible, you should switch over to green chemistry.
Yes, sir. Thank you, sir.
Yeah.
Thank
हॅलो सर,
Yeah.
ओल्या कचऱ्यापासून आपण ऑर्गॅनिक फर्टिलायझर बनवू शकतो का? आणि बनवू शकत असेल तर कमी किमतीत शेतकऱ्यांना प्रोव्हाइड करू शकतो का?
बिलकुल, म्हणजे बनवता येतं. ओल्या कचऱ्यापासून आपल्याला ऑर्गॅनिक कचरा, त्याचे दोन ऑप्शन्स आहे. मी एक स्लाइड तुम्हाला दाखवली होती. ओला कचरा, त्याच्यापासून तुम्ही मिथेन जनरेट करून एनर्जी जनरेट करू शकता, किंवा तुम्हाला मिथेन जनरेट नसेल करायचा तर डायरेक्टली तुम्ही त्याला कॉम्पोस्टही करू शकता. म्हणजे दोन्ही ऑप्शन्स तुमच्याकडे अवेलेबल आहे. पण हे तेव्हा शक्य होतं जेव्हा तुमचा वेस्ट तुम्ही प्रॉपरली सॅग्रिगेट केला. समजा तुम्ही सगळं वेस्ट ओल्या कचऱ्यामध्ये बाकी वेस्ट सगळं मिळवलं, समजा त्याच्यात हेवी मेटल्स असतील, सगळे असतील, तर त्याच्यापासून जे तुम्ही कॉम्पोस्ट तयार कराल, ती कॉम्पोस्टची क्वालिटी तुमची चांगली राहणार नाही. तर समजा तुम्हाला चांगल्या क्वालिटीचा कॉम्पोस्ट ओल्या कचऱ्यापासून बनवायचा आहे, तो ओला कचरा प्रॉपरली तुम्हाला कलेक्ट करून मग त्याच्यावर तुम्ही प्रक्रिया करा याची आपली कॉम्पोस्टिंगची, आणि यू विल गेट व्हेरी गुड क्वालिटी कॉम्पोस्ट फ्रॉम दिस वेट वेस्ट, ओला कचरा. तर ऑलरेडी याच्यासाठी खूप साऱ्या टेक्नॉलॉजीज अवेलेबल आहे आणि बरेच लोक प्रॅक्टिस करतातही आहे. मी जे तुम्हाला एक्झाम्पल दिलं गोव्याचं, गोव्यामध्ये हीच प्रॅक्टिस आहे. ओला कचरा सॅग्रिगेटेड फॉर्ममध्ये येतो, त्याचं ते डायजेशन करतात, डायजेशन करून त्याच्यातून मिथेन जनरेट करतात, मिथेन पासून ती स्वतःची इलेक्ट्रिसिटी तयार करतात आणि ती विकतात इलेक्ट्रिसिटी, आणि मिथेन बनवल्यावर जो रेसिड्यू राहतो त्याचं ते कॉम्पोस्ट करतात. हे कॉम्पोस्ट मध्ये फार्मर्सला किंवा कुठल्याही एजन्सीला ते विकतात. तर ही ऑलरेडी एस्टॅब्लिश प्रोसेस आहे ओल्या कचऱ्यापासून कॉम्पोस्ट बनवणे, आणि बिलकुल शक्य आहे ते करणं. येस,
थँक्यू सर.
या. एनी अदर क्वेरी?
Dr. Mahedra.
Sir, एक क्वेश्चन.
Continue, please continue.
सर, जे म्हणजे जे ऑलरेडी कंबस्टेड आहेत जे वेस्ट, त्याला कसं ऍक्च्युली त्याचं मॅनेजमेंट कसं करतात? जसं एक आपण बघतोय की हे आपल्या ऑटोमोबाईल्स मधले जितके पण ऑइल्स आहेत, इंजिन ऑइल्स वगैरे, ते वेस्ट मध्ये ऍक्च्युली मोस्ट ऑफ द हे काय करतात की सरळ म्हणजे फेकतात बाहेर, जसं ट्रकचं असो किंवा आपल्या ऑटोमोबाईल्सचं असो. सर, त्याचं कसं वेस्ट मॅनेजमेंट कसं करू शकणार सर आपण?
त्याचं वेस्ट मॅनेजमेंट, जसं मी तुम्हाला सांगितलं की रूल्स आहे आपले, हॅझर्डस वेस्टचे रूल आहे. त्या हॅझर्डस वेस्टच्या रूलमध्ये एक शेड्यूल स्पेसिफिकली या वेस्ट ऑइल किंवा याच्यासाठीच त्यांनी दिलेला आहे. याची जेवढे जनरेटर्स आहेत, समजा गॅरेज म्हणा किंवा काही, यांचं जे वेस्ट आधी फेकायचे ते आताही समजा फेकत असतील, पण जे फेकणार जी प्रोसेस आहे ती दॅट इज इलिगल. तर त्याला न फेकता तुम्ही तुमच्याकडे एक मोठा ड्रम तयार करा. समजा माझं गॅरेज आहे, माझ्याकडे गाड्या येतात, तर त्यातलं जे वेस्ट ऑइल जे निघतं, तर मी एका ड्रम मध्ये त्याला कलेक्ट करून स्टोअर करेल, आणि त्याचे ऑथराइज्ड एजन्सीज आहेत ते हे सगळं वेस्ट ते तुमच्याकडून घेतील. समजा त्याच्यात काही त्यांना पोटेन्शियल असेल तर दे कॅन पे यू सम मनी, आणि हे वेस्ट ते घेऊन मग ते पुढे त्याला प्रोसेस करतात, त्याला रिफाईन करून त्याच्यातून पुन्हा ऑइल बनवतात. समजा रिफायनिंग पॉसिबल नसेल तर ते समजा सिमेंट इंडस्ट्रीला विकतात. तर सिमेंट इंडस्ट्री त्यांना फ्युएलची गरज असते, दे यूज कोल. सो इन्स्टेड ऑफ कोल दे यूज दिस काइंड ऑफ ऑल्टरनेट फ्युएल, म्हणजे जे वेस्ट बेस्ड फ्युएल, आणि ते वापरतात. तर हेच आहे की जे रूल्स आहे, रेग्युलेशन्स आहेत, त्याच्याप्रमाणे आपण सगळ्यांनी वागायला पाहिजे. समजा मी वेस्ट जनरेट करतोय तर इट इज माय रिस्पॉन्सिबिलिटी टू कलेक्ट, स्टोअर अँड डिस्पोज ऑफ दॅट वेस्ट प्रॉपरली. समजा आपण फेकू तर इलिगल होईल, आणि इफ इट कम्स टू द नोटीस ऑफ रेग्युलेटरी एजन्सीज, ते तुमच्या अगेन्स्ट ऍक्शन घेऊ शकतील, तुमचं जे काही एस्टॅब्लिशमेंट आहे ते बंदही करू शकतील.
थँक्यू सर.
Yes, so if no more queries, I think we can close this.
Dr. Mahedra,
Yes.
just I would like to know from you that what is the solid waste pollution scenario of our Nagpur city at present?
At present, Nagpur city, previously it was done by different agency, but whatever we have done in the past many decades, the management of municipal solid waste in Nagpur was not very scientific. But now recently Nagpur Municipal Corporation has taken an initiative. As I told you, we have municipal solid waste management rules 2016. So as per these rules, all the municipal corporations, they are required to collect their waste in a segregated manner, and they are required to establish a municipal solid waste processing management facility for their city. So all the municipal corporations are now switching over to that. And similarly, Nagpur also, they have engaged one agency, Susbidi. Susbidi is a Netherlands-based company. They have engaged, they have given a contract to them. So they will be collecting, Nagpur Municipal Corporation will collect the waste and they will hand it over to this agency. So they will do waste segregation for dry waste in different fractions. And again, the wet waste, they will be converting it into methane, and this methane they will be converting into the compressed natural gas. And this natural gas will be given to, I think they have a type with Hindustan Petroleum Corporation, HPCL. So whatever gas they will be generating and compressing, they will be giving to HPCL. So maybe in another 1 year's time, Nagpur will also have a very good system for management of municipal solid waste. So it has just started in last 2-3 months. NIRI is also associated with them. Whatever DPR was prepared for this plant, it was vetted by NIRI, and we are also giving our expert services to Nagpur Municipal Corporation as well as the agency, this Netherlands-based agency. We are giving our services to them. So hopefully in another 1 year's time, we'll have a very good system for municipal solid waste management for Nagpur.
Okay, thanks. Any participant would like to ask any question? Otherwise, I would like to request Ms. Kanimozi, please propose the formal vote of thanks.
Okay, thank you.
I would like to thank her for giving a detailed explanation on various categories of waste like solid, liquid, biomedical, e-waste, construction, demolished waste, plastic waste, as well as battery waste, and hazardous and non-hazardous waste. You also clearly pointed out the challenges associated with waste management as well as various Environmental Protection Act, and what are the technological interventions needed to enhance waste management were clearly discussed with examples. At last, you also touched upon treatment option available for all the types of waste. Thanks a lot for your clear presentation and also answering our queries patiently. I thank you once again on behalf of everyone present here. Thank you, sir.
Okay, thank you.
Thank you, Mahedra.
Thank you. So I'm logging off now. Okay.
Yeah.
Thank you. Thank you everyone for your patient hearing.